Okay, so you have this reference guide in your notes. I'm just literally going to make this like a 2-minute video. You don't even have to write anything down. Just listen. So special cases in algebra is a whole unit by itself because some have no solutions or infinite solutions. We just spent like 3 videos figuring that out. This is just a summary for you to look back to, okay? When you graph, 3 things can happen. This is how I started the unit. I graphed it and they met at 1 point, meaning there's the 1 point. They could meet nowhere, which means they're parallel, which means they have the same slope but start at a different spot. And then infinite solutions is where one line is literally on top of the other. Okay, so this would look like something like this. Y equals 2x minus 1, y equals 4x plus 7. Okay, those are not the equations of these lines. I'm just saying they don't have the same slope, so you know they're not parallel, and they're starting in different points. Yep, they'll touch. You don't even need to see these 2 graphed to know that these are going to have one solution, right? Okay, now this line would look something like this. Y equals 2/3 x minus 6, y equals 2/3 x plus 5. Again, they're not the exact equations, but as soon as you see that they have the same slope, but they're starting in a different spot. Again, you don't even need to graph them. You know they're going to be parallel, which means no solution because same slope, right? This line is actually easy because it's the exact same line. Y equals 2x minus 1, y equals 2x minus 1. Now, not only are they starting in the same place, again, different line, they are having the same slope. Okay, so if you were to look at this, then you would know, oh, they're the exact same line, infinite number solutions, okay? Now, when you do substitution or elimination, this is what it looks like. So take a peek here. When you go and you either substitute it in and you get to this point right here, as soon as you get to this point right here, where you did your substitution and you found that there was still a y left, you can stop. If I don't need the solution, you jump right here and say, oh, no, one solution. I know there's going to be a solution because there's a y to solve for, okay? If you see an equation that they're already set up and not just one variable, but both variables cancel, you have nothing on the left. You have to add up the right and see if it's true or false. So because both of these variables canceled, 0 does not equal 8, and it's false, which means there is no solution. These will never meet. Look, it's these if I graph them. That's why these are lined up with each other, right? Okay. And then after I did some fancy work and got it all together and did some substitution, I found that my x's canceled and I had -1 equaled -1. That's true, which means, yep, infinite solutions. So I want you to take a really good look at this sheet of paper because this is a visual representation of what this means. So this is the one solution column, this is the no solution column, and this is the infinite solution column. That's a nice review.